All right, thank you for joining us today for this webinar on instant mainframe storage. I am Dustin Froy. I'm one of the co-founders of VirtualZ, and thank you to Vince Ray, our CTO and co-founder as well, and also our special guest, Carlos Marquez from our partner Mainline Information Systems. Carlos is the Director of Technology and an enterprise architect, and so we're really glad to have Carlos with us today. We're going to talk a little bit about understanding what instant mainframe storage means and kind of the innovation around that. Carlos is going to talk a little bit about the market need for on-demand mainframe storage. And Vince and I will discuss VirtualZ mainframe storage solution, how it works, the architecture, and then we'll have a little time for Q&A and conclusion as well. And like I said, please drop your questions in the chat, and we'll monitor those as we go as well. Okay, so what is instant mainframe storage? So if you look back at kind of traditional mainframe storage, either channel attached, network attached, DASD tape systems, virtual tape systems, that's really been the legacy of mainframe storage. But with the dawning of the cloud, it opens up a lot of additional opportunities that have really been available to distributed environments for quite a while. And so that's really what we have brought to the mainframe. So allowing both virtual disk and virtual tape to go to the cloud, or even actually physical SAN storage if you want to stay in your data center on your network, et cetera. So this really opens up the possibilities of additional storage options for your mainframe that can be extremely high performing, very similar or exactly the same as your channel attached storage, depending on how you configure things. This is no code. Well, one of the big advantages is the on-demand provisioning, right? If you're familiar with ordering traditional DASD and how that process works, imagining using white space in your SAN solutions or just bursting out to the cloud, just like other environments have done for quite a while now. There's a great savings opportunity here. The cloud providers have done a lot of work on pricing their storage solutions appropriately to be extremely cost competitive to some of the other storage options, let alone mainframe DASD and tape. And again, this gives you additional opportunities to select your storage for that particular need. So Carlos, I wanted to really ask you about what you're seeing in the market, both from the customers, suppliers, those types of things. And kind of what's your perception in dealing with your customers and really operating in this space?
Yeah, thank you, Dusty. So I think as a seller of mainframe systems and mainframe storage, I think we have a lot of customers who are dealing with constraints when it comes to storage capacity. I think that there's obviously very few choices in the market when it comes to mainframe storage, block storage. So it typically is a higher cost per terabyte. And so that obviously has its challenges from an acquisition perspective. You also have challenges around just around having those conversations, especially if you're a smaller mainframe shop. A storage subsystem, depending on configuration, could be a $100,000 plus purchase. And there's been some changes in the market recently with price increases across the board on different components. So that obviously trends to the $200,000, $300,000 range for even a relatively small configuration. So and then you have lead times for that equipment. And you may only need capacity for a temporary purpose. You might want to do some testing. You might want to support a AI or other type of hybrid cloud initiative where you might need some capacity that you don't really want to hold on to. But that's that's obviously difficult to do with the storage arrays today on the mainframe. So I think those are the main things. I think the opportunity that we have in this case is that we can marry the mainframe block storage with a something that looks a lot like block storage, but it is from a cloud provider or from another storage array that the customer may run their open systems infrastructure on. So something that has an NFS mount or an S3 source, so that we can very quickly provision those things. Those things are usually very well understood. And so the opportunity here is to be able to leverage those types of capabilities that customers typically already have or have access to very quickly, either for non-production needs for some sort of POC or for some sort of new initiative where they wanna try something out. So so that obviously is something that is a good opportunity for our mainframe customers.
So Carlos, with your kind of traditional direct attached storage, what's usually the lead time and kind of the install cycle for that? What's normal for you guys and your customers?
It depends. I think we typically work off of a 1 to 2 month lead time. Um, we have a very because of the criticality of a lot of these systems, we have it's a heavily change controlled environment. So even if we can get the equipment on site, we're typically restricted to change windows, and a lot of our mainframe customers restrict their change windows to it's not even a weekend thing anymore. It might be even a quarterly thing, or twice a year type of change windows, depending on what it is. So it's really a combination of the lead time to get the physical equipment on site, make sure we can plug it in, install it, and make sure everything's good. But then to not only do the physical install, but then do any kind of data migration as well. So I mean, these lead times are in the months typically.
Yeah. And do you have customers that are being challenged to meet kind of their cloud commitments as well, where this, balancing out both their, on-prem storage and their cloud storage could really help that? Or is that really not an issue you're seeing in the market?
Yeah, that's definitely another opportunity for customers who do have committed spend in the cloud, or have a presence in any of the public clouds. Is they typically will have a hybrid environment. Well, they'll have mainframes and some open systems on prem, and then have cloud commit. So that is another opportunity. So very few of our customers these days that own mainframes don't have a cloud presence, have zero presence in the public cloud. So there's obviously an opportunity there. And very few of them don't use network protocols like S3 or NFS. So there's opportunity there as well.
Okay, great. Anything else you'd like to share, Carlos? I know we'll kind of get into the architecture here, but and I got a couple questions on use cases. Maybe you can comment on those too. But anything else before we move on to Vince and maybe talk a little bit about the technology and the architecture?
No, I just think this is, again, a great opportunity for especially our smaller customers who don't, when they do touch their mainframe environments, it is a heavy lift for them, both expense wise as well as process wise. And I do think it's a great opportunity for some of them to explore new workloads, new projects, by being able to leverage storage that they're already using for other things today, and not have it be some one-off solution. But it's really a great opportunity to explore it at a very reasonable price point. So I think it's something that hopefully will accelerate some innovation for our mainframe customers, and help them look for an opportunity to make some money, or to be able to do something to help their customers. So
Great. For those just joining, feel free to drop questions in the chat and we'll try to address those as we go here. All right, Vince, you want to talk a little bit about how it works and the kind of the technical overview? Maybe starting with where does it run? Where does Zaac run in the environment?
Yeah, well, happy to go into that. First, let me make sure you guys are able to hear me. I had some microphone issues today.
Yep, we're good, Vince.
Okay, great. So Zaac is 100% mainframe software. You install it on ZOS like any other ZOS software, and it connects to whatever targets you want. In fact, that's one of the strengths of Zaac is that it's open in that regard. It's it's able to connect and support storage, whether that's on-prem or in the cloud or a mix of both. And we don't require any software at all on the target. So, there's nothing that you run in Amazon. There's no middle tier in between your mainframe and where the storage is. We talk directly to whatever the storage provider is using the normal protocols that that cloud provider uses. The way I like to think of it is that it's very similar to what you might do on, let's say a Windows system or a Linux system. You might have a server in your data center running Windows or Linux, and you need more storage. And the way you do that might be to, just go buy some storage in the Amazon cloud, connect in, and it looks and acts and behaves all the world like it's local storage on your whatever that Intel platform is. What we've done is bring that same idea to ZOS. So you end up with a way of accessing cloud storage just as though it were local mainframe disks and tapes. And that's really the strength here. What you create looks and behaves exactly like any other mainframe disk or tape device would act. If you want to create, I don't know, VSAM files or DB2 databases, or you've got some vendor product that's doing really low level I/O to access its data sets, all of that works perfectly fine over Zaac, because what we're providing is virtual disk, virtual tape. It just happens to be virtual disk backed by storage in whatever cloud or on-prem configuration that you want. So any application can work with Zaac. There's nothing to change. There's no proprietary API to call. You just open, close, read, write, all the normal things that you would normally do to access mainframe data works the same exact way with Zaac, and that includes, by the way, as I said, things that do low-level I/O. So DB2 databases, programs doing EXCP access to get to their data in a low-level way. All of that continues to work completely unchanged. The application just sees either a mainframe tape device or a mainframe disk device backed by storage that's managed by Zaac. It's also dynamic. You can add devices, remove devices, change where they're going, really minute by minute if that's what you want to do. Typically, this would be something like an operator command. The operator at the console says, "Hey, go access this virtual disk in the Amazon environment and make it look like this volume to my mainframe applications." 5 minutes later, he could do the same thing, but now maybe that device is backed by storage, I don't know, in an on-prem environment, an environment that you got sitting right in your data center. So it can adapt. And again, that's one of the big differences here. It's not like uh, what you heard a few minutes ago. You got to do all of this planning and bring in physical disk and install, and none of that happens with Zaac. With Zaac, you can just decide spur of the moment, hey, I need a few terabytes, let's say, to do some application testing. I sit down, type in a few commands, and I've got the storage I want online at that point. And then and this is really the other side of that. When you're done with that, it's the same process to get rid of that storage. So, you get to turn it on and off at whatever scale you need, going to whatever targets you want, completely dynamic and in a, on-demand way. The resiliency, naturally, especially if you're talking about cloud providers, everybody is concerned about, performance and resiliency and, what happens if there's a network outage. So, one of the really unique parts of Zaac is that we've included a very sophisticated caching and journaling system that hardens updates to the virtual disk or tape using native ZOS facilities, specifically, system logger and log streams and all of that, and VLF for our caching capabilities. What that means is when you have an application that does a write to a virtual disk, it's going to update a virtual disk that maybe is living in, God knows what cloud. As soon as that write occurs, it's journaled into the system logger, which, big parallel sysplex resource. And as soon as that data has been hardened into the journal, your I/O is basically done. We know that that data can't be lost at that point. So that allows us to asynchronously update the cloud as it's available. So if there should be, let's say a network outage at that point for a few seconds, doesn't really matter to us. Your data has been captured. The change data is captured locally on ZOS, where it will, eventually be applied to the target in a consistent way so that there's no chance at all of data access. We also support duplexing. So, an unusual, many of you, if you run large mainframe sites, you might be doing things with GDPS or with, data replication so that you have copies of your data in multiple physical locations. Zaac can work the same way. So you can configure Zaac that says, when I create this virtual disk volume, I don't want it just backed in Amazon. I want one in Amazon and let's say one in Microsoft Azure. And then, they cooperate in a fault tolerant way so that, again, if there is any kind of outage, you have that immediate failover to, a completely different cloud environment. That can also work with, on-prem and cloud, or on-prem and a different on-prem, giving you something a lot like GDPS at a much lower cost, and something that can be done in a, very granular kind of a way. So that whole approach of, how do I make my storage environment safe and resilient and fault tolerant and all that, many new options pop up with Zaac that have just been either available but really expensive, or difficult to use in the past. With Zaac, it really is as simple as I want one copy on Amazon, one copy on Azure, and the system takes care of the rest beyond that. So when we also talk about security, I mean, a lot of my personal background is with mainframe security, and it's something that's near and dear to my heart. A lot of times we see data sharing solutions, and the idea is as soon as the data is off the mainframe, you're kind of depending on some other platform to take care of it. Well, with Zaac, you have the ability to, certainly if you want to leverage, let's say what Amazon provides or Microsoft provides, and you want to use their disk encryption and, all their other features, absolutely you can do that. But we can also do the same type of thing on the ZOS side. If you're using IBM's encryption at rest features, or vendor products that are doing encryption. Again, all of that continues to work unchanged. The protocols we use to talk to the cloud provider can also be encrypted. And again, it's up to whatever the cloud provider supports. Amazon, for instance, out of the box, the default is that all the network traffic is encrypted. We support all of that. We also have the option to do our own level of encryption on the data at a volume by volume basis, so that you can control access that way. And of course, even after you have that data mounted, because it looks like a local disk to you, you have all of the normal mainframe security controls at your disposal. If RACF or top secret or ACF2 or whatever you're running for security is protecting, let's say a vSAM file, when Zaac hosts it, it's still protected by the security policies that you set up. There's no change there. You don't have to rethink who should have access to this, how is it being accessed. That all stays exactly the same. Because from the application's point of view, it's the same data. It's just a volume that happens to be in the clouds rather than somewhere else. So yeah, it is kind of a different way of thinking about storage. Low cost is certainly part of it, but it's not just low cost. It's some new qualities of service like the duplexing I described. It's high performance because of the journaling and caching that I described. And there are many unique capabilities built into Zaac that give us a very credible alternative to traditional disk that can be hosted really anywhere that you like. Last thing I'll mention is that what we do in Zaac is also open. The protocol that we use to talk to the cloud provider, as I said, is defined by the cloud provider. What we've done is we've created, you could almost think of it as a device driver model around that. And it's not just us who can write those drivers. If, and I'm making this up, but let's say the folks at Dropbox said, oh, that's a cool feature. I'd like to use Dropbox storage for, mainframe disk. They could actually go off and write that driver that we require to the spec that we provide, and then it would plug in and support their environment. So what that really means is it's completely open-ended. Anything that we can develop or a third party can develop a driver to talk to is possible to use for virtual disk and virtual tape. So that means it's not just the one or two or three that we want to do. It's really open to whatever your requirements are. And again, we don't care what's on the other side of that driver. It could be a cloud provider, it could be an on-prem device, it could be an iSCSI device, it could be whatever you happen to have. Can be supported that way, and you get all of the features I'm describing, no matter what the underlying storage mechanism is. So, Dusty, did I forget
Yeah.
anything? Any big points?
No, that's great, Vince. Thank you so much for that detailed overview. So I'm gonna bring up a couple use cases, and I want to quiz you, Vince, and Carlos as well. But I want to highlight a few things. Right, we've talked a lot about the enhanced agility and elasticity, being able to go, either use commodity SAN or even to burst out into the cloud. And because of the open architecture, this is really future proof, right? So you can, as new storage capabilities come available in the cloud, you can really move along with those without having to, go to a new generation of hardware, firmware, other surrounding software that helps manage that. One of the things I really wanted to talk about is kind of the improved disaster recovery. The worst outage that I experienced in my past, and now with kind of the ransomware and those types of things, was really storage hardware related. And it was a bug in the microcode, and it caused a very long outage. I really think, and we're seeing this in some of our customer interactions as well, right? They want a tertiary or quaternary copy. Maybe it's just sitting in Glacier, very, very low cost storage, but essentially air gapped from their hardware, their other systems that they could recover from. So Carlos, is that something you're seeing in your customer base as well? Is wanting to have that application data backup and recovery capability or a tertiary copy? Is that an emerging item for your customers?
Yeah, absolutely. Especially for cyber resiliency and for lower cost storage. Absolutely, it's definitely something that we're seeing.
Okay.
Dustin, you have a question?
Also, there's a question in the chat.
Okay, great. I don't see it, but
well, it's a hand up. Aaron, if you want to talk, I'm not sure if we'll be able to hear you or not. If needed, I can make you a presenter. Otherwise, we might need to use the chat. Aaron, if you talk, let us know.
Yeah, can you hear me?
Yep, we can hear you. Great.
Okay, yeah, I tried to type into the chat, but I couldn't get the chat to work. So with Zaac and mainframe cloud storage or mainframe storage in the cloud, if a client's got a hybrid environment where mainframe data is being shared with other platforms, what is the impact from an egress charge perspective if data is continuously being pulled back down from the cloud and shared with other platforms, whether they're on-prem or also in the cloud?
So there's definitely an egress charge, right? And it varies a little bit depending on that class of storage. One of the things that's great about Zaac is being able to do, if they have lots and lots of egress and it's, that's very high performing, that's where using SAN can come in as well, right? They can use that on-prem within their network. And that can really mitigate any of those network charges. But again, that's something they do need to factor in when they're looking at, what is the right solution in architecture for, non-direct attached storage. Carlos,
Yeah,
anything?
I think if you're using a cloud provider if you use S3 and you're pulling data and there's an egress charge anyway for whatever is talking to it, that egress is going to be there. I think there's other cloud storage services where they don't have an egress charge. So, as long as it's S3 compliant, Zaac would work with it. It just becomes some cloud providers are going to charge you egress for pulling data out, and some aren't. So I think that's
okay.
I think that'll be the same answer regardless of the solution.
All right, thanks.
That help?
All right. Other questions? Vince, do you want to just talk briefly? I know this question comes up in my discussions quite a bit. I mean, you mentioned kind of the compatible S3 compatible, but it's also NFS compatible storage. Anything else you would add about the protocols that we support today?
Yeah, no, happy to spend a moment on that. We, as I said, the design we have is open and it allows us to plug in anything that customers ask us for. So if there's a business case, we can generally support it. Out of the box, we deliver, it's today it's 4 things. It'll probably shortly be 5 things. One is Amazon S3 compatible. And there are many things that implement S3. That doesn't necessarily mean you have to go to Amazon. IBM's cloud, for instance, supports the S3 protocol. So, as long as it's protocol compatible to S3, we would support it. So that's one universe. Number 2, we also support Microsoft Azure's protocols. So you're free to create virtual disks in Microsoft, and then same for Google. So those 3 are in the box. We also add some of the cloud environments have high performance server storage that they implement over NFS. So instead of knowing how to talk S3, they basically give you an NFS mount point that you can, essentially just read and write to. We support that as well. That gets you into not just cloud providers, but if you had, let's say a SAN environment that had an NFS look to it, you would be able to use that driver to support your local SAN devices. And then the one that's still in the lab being baked is the iSCSI support. So we can take pretty much any SAN environment that can create an iSCSI volume, and then use that iSCSI volume for Zaac storage. That would be much higher performance than the NFS solution I described, and it works, pretty universally with most of the SAN providers out there. So, in Carlos' example of, you may have a lot of storage laying around that you're using for other platforms and you like to provision some of it and use it for your mainframe, that would be a perfect case. Go into the, whatever SAN management software you're using, create some iSCSI accessed from your mainframe. That one is particularly interesting to us because in a modern mainframe with very high bandwidth connections, that approaches channel speeds in terms of the throughput that's possible to get in that environment. And again, it's going to depend on how much network you have, how far away that SAN is, and all of the usual factors there. But it seems like that feels like a very credible way to extend mainframe storage at very low cost without without having big latency or slowdowns there. So as I said, others are possible. Certainly if somebody brings us a great idea for hey, you should support fill in the blank, that's a conversation we'd be happy to have. And it's, and as I said, it doesn't even really have to be done by us. If you could convince, Dropbox to develop a connector for their platform that runs inside of Zaac, we'd be happy to work with them and show them how they could write that software too.
Okay, great. Any questions that I've missed? All right. If you'd like to get in touch with Carlos, here's Carlos's contact information, and I'm sure he'd be glad to help with implementing this solution in partnership with us. Carlos, anything else you want to mention about Mainline and your services?
No, I think we have a few people from Mainline on the webinar, and yeah, we've been doing IBM full stack services for a number of years. We have managed services. We obviously resell the systems, the software, the storage, the tape. So we understand a lot of this. We've had dozens of people who work in this space. So we obviously we think we're pretty good at it. So we obviously would love an opportunity to have a discussion and work with you guys on a project. So
great. Well, thank you so much for. Oh, sorry, Carlos.
Yeah, and I just want to go back to the to Aaron's question again about egress and what Vince said. There are, like I mentioned earlier, this is for S3 storage. There are plenty of S3 compatible offerings out there that don't charge egress. Like a Wasabi, for example, or others where that would not be an issue. Or if you're using the solution as sort of a third copy, chances are you're only going to be bringing back the data in very remote cases too. So a lot of different ways to skin it where we could avoid egress charges in general. So I just want to make sure I answered that fully after thinking through it some more. So
yeah, no, thanks, Carlos. Yeah, and again, if there's yeah, like you said, there's many different options. Please reach out to Carlos or ourselves, and we'll help you get to the right solution there. Thanks again, Carlos, for giving your time and joining us for this. If we have a lot of other resources, if you would like them, and they are webinars and other blogs. We have other data access solutions as well. So really, there's just really an unlimited number of use cases that we can address through our solutions, including Propels and Lozen. So yeah, please reach out, check us out. And again, thank you for joining us today, and look forward to connecting with you.